Okay, it's 11 o'clock, and over the next hour, I'm going to go through the last two sessions here, the NMR module and the fluid flow simulation module. And so the first, for the NMR module, I've made up a little model here where I have imported two sets of data. One is a bunch of well logs, and the other is NMR T2 data set. I plotted the data set here, and some of the logs I've plotted. I have gamma ray and some nuclear. And then I use those to basically make up, in this first track, an Earth model that I want to use to try to demonstrate how we could use the NMR module to evaluate the Earth model and see if we can come up with an Earth model that will give a similar simulation that looks like what I've imported here. So, you know, I could see down here we have a water reservoir, so I made a water oil contact here, set up a increasing or decreasing water saturation up here, and here we saw some, it looks like some shale laminations, and then up here we clearly had some gas. So I set that to gas and then put in some shale in other places based on the gamma ray. And so what we're going to do now is going to click this button up here, which opens up the NMR Studio. And I'm going to, it's designed to sort of go from left to right, except for the second tab here, which is the import tab, which I'll just show quickly how we imported this log. And so if you have data and you want to import it, you can go here and you can either import it first using the normal log set import and then use this to make a data set out of it. Or you can import it directly from the file, which is what we've done in this case. So if you go here, both of these data sets are in the folder that that are associated with this presentation. So you can, for instance, select the T2 distribution. Now, this will also work. This is a DLIS file. It'll just bring up the DLIS opening window, and you can work that way as well. Oh, I forgot to hit. Yeah, well, anyway, it's there. Okay, so then once you've selected your source, and you can select load, and it will say, oh, well, there's a couple of different arrays in that log set, or in that last file. And so you can select the one that you want to be associated with the data. And, and then that'll import that in here. And it says, you know, we have an array with 121 points per depth. And down here, you can get some views at different depths of what this will look like for your settings. You can select the type of data you have. It can be T1, T2, T2A, diffusion, or if you have, you can also import magnetization decays, in which case you click magnetization. And then down here, you pick, based on what you're importing, you can pick the domain. That will change what these values are here for each of the points. It'll just distribute them over the points in the appropriate manner. And if you have, in this case, it found a header in the file, so you can click Use Header, in which case you can see this changes to match whatever the settings in the header were. Or if it doesn't have a header, then you need to set the appropriate row here. And in this case, I mean, I already have this set, so they will both give the same results. And then you hit, oh, well, you can also set the name. If you import more than one, you can set different names. Then you hit import, and then what you see is up here, it creates a NMR data set, different from a log set because it contains array data. In this case, it shows you that the size of the T2 data is 150 depth points by 121 time points. And so we show that here. And now what we want to do is we've already if you want later on, you can use these logs and you can try to set up this Earth model yourself. Basically, I use the same tools that Joaquin has been showing you over the last couple hours, as far as populating logs and doing calculations and things. But now we're going to take what I've initially set up and try to see what we get from our Earth model or our NMR calculations and simulations. So the first thing you have to do if you want to do a simulation or just a calculation is you need to do a calculation in the Earth model. What this does is it uses a lot of the properties in the Earth model in order to calculate for each layer in the Earth model what the NMR signal should be from that layer. And there's two ways of doing that. We have the old way of doing it, which is sort of a simplified relaxivity domain. The advantage of the relaxivity domain, I'm going to use that just on the first calculation here, because it gives you an estimate of all of the different types of data you can get. It'll give you T1, T2, give you 2D arrays. It'll give you diffusion and all that stuff. The time domain will just calculate based on the settings that you have in the Earth model. Will calculate what it expects the decay curve or the time decay of the magnetization to be for that, and it'll store that in the Earth model. And then you can invert that, or you can simulate it, or you can use it in a number of ways. So I'm just going to run this calculation first. It takes a little bit longer because we're doing both. In this first one, we're doing the relaxivity domain and the time domain. And for the relaxivity domain, it'll also use what you have set in this table here for the different values. So this determines what domain you're going to have for the T1, T2, and D. You can set a noise. We usually have a little bit of noise, but you can either have that included or not included. And this DOI is kind of important because you don't necessarily, NMR is, only operates within inches of the borehole. And so you don't need to do these calculations. If you had created a lot of, especially like if you did a fluid flow sim where, you might have out to 5 meters or something, you don't need to do calculations or simulations on that entire range. So you just have applied DOI and just go out to like a 1/4 foot or something, 6 inches. And in this case, for our simulations, they only do out to 4 inches. So now we have that done. And so the reason I wanted to, I'm going to turn this off because we're not going to use it again, but since we already have now in the Earth model, we have relaxivity domain data, so I can use that to help show the kinds of plots that we can do. So these two windows are for doing detailed view on different layers of plots. And so here you can see for the time domain, as I said, it only calculates the magnetization curves. And over here in the partial porosity plots or the distributions, we don't have anything. But if we go to the relaxivity domain, then you can see that we have, both it calculates the decay curves as well as the distributions. And it actually calculates, in this case, it calculates the decay curves from the distributions. And it calculates these first. And you also have the different types of data. So the RD data gives you all the different possible types of data that you might have. And as you know, you can also use this to compare, since we already have field data, we can compare the field data to the, here it's a little hard to see when you have all of the layers showing, but you can compare the field data to, for instance, the Earth model or simulated data. This is more useful if you just want to compare a single layer, for instance. And here, there's these buttons here that for the field and simulated data, because there's usually so many depths, so you can just select the one that's in the center of whatever layer you're using. So in this case, it matched the layers, and you can see now we have the field data versus the Earth model data for that layer, and you can use those to compare individual layers. And then for the RD data, we also have the 2D plots. And so here you can see that that we have. So for instance, in layer 4, we have some gas up here. But if we went to, layer 40, or something around there, then you see then we have, oil and water mixture in that layer. And so you can look at these. This is like the DT2, but you can also look at the DT1 and various things like that. So those are the plots. And now what we're going to do, though, is since we already have that time domain decay, those time domain decay curves, and so what we want to do is we're going to do a simulation based on those. And what the simulation does, like all the simulations, it will take into account the things. It takes into account like nearby effects, either different zones, different depths of investigation, or it'll take into account nearby layers and things like that. And so it'll account for the changes at different depths, and it also gives you regular depths rather than just the centers of the layer centers. So now we did that simulation. In order to use that data, then we need to invert it. Now we could invert the Earth model, but in this case we already simulated. We used the Earth model to create the simulated decay data. So now we're going to do that. And so thought we simulated it. Try that again. Maybe I didn't hit simulate. Okay, so now we should have, there it is, simulation. So now we hit the simulation. You can select the layers, or the depths, not the layers really, the depths that you want. Shells. If you have multiple sequences, you can select those. And then in this case, this can try to estimate a regularization for the inversion. In this case, I'm going to set it to be 2. And then this is the output data set name. So this is going to, you notice that we already, we could change it and put in a different data set, but I'm going to leave it in the data set. By default, if you select the data set up here, it will use that as the output. So here we already have, because we did the simulation of the decay data, we have the decay in the phi NMR. So now we're going to run this, and this should add into this a T2 or a T2A really array. And so we give that, I think this will take about 30 seconds. This has, but in here, as I said, you can do the Earth model, and also the Earth model, you can just use the settings that are in the Earth model calculator, or you can select specific layers and zones and sequences. You can play with all these things too if you want to try, and these are more important probably for when you do more complex sequences. Then you may by default it will pick some different, definitely different kernels, but also you can have different solvers and stuff. So now this is updating the results. Okay, now you see we have a T2A data up here in that simulation. So now we can actually plot this. And remember, I was using this just using the default settings. And so I'm going to go to simulated data, and we'll go to logarithmic, make it 4, so we match. So now we can see we have 0.3 to 3000, like we do here. It's a little bit bigger. And then, whoops. And okay, and then we can change the scale to make it look a little bit more like the other one. 8. Okay, so how did we do? Well, we can see already that, this looks more bimodal. This does not. Some of these other things don't seem to be quite in the right spots. This seems to be off, and so we're going to do some adjustments on this and see if we can do it better. But the first thing I want to do before we do that is to finish up these tabs and show you the final tab, which is the log sets. And these are NMR log sets. either permeability calculations based on logs, or you can do binned log sets based on the T2 data or any other data really. Mean value log sets and NMR porosity if that data is available in the NMR data. And this these down here work on an NMR data set. You know, we have 2 of those NMR data sets up here, so you can either use the NMR data or the NMR data or the NMR simulation. So for instance, if we want to, even if you just have imported data, you can calculate any of these things. If you don't already have the logs, like the binned logs or the mean value logs, you can calculate those here. In this case, for instance, on the NMR data, I'm going to add a mean value log set. I'll just put a D at the end of that for the data. And so then if we look up here, now we have a T2LM and we can plot that over this data. And, oops, sorry, we need the simulated log. And you can see that's there, and we'll make it thicker so that way it's easier to see. And maybe a different color. Okay, so there you can see the T2 log mean. And now for the for the simulated data, we're going to do both the log mean and the Teemer-Coates permeability, and I'm also able to do the SDR permeability up here. If you want to know what these are, by the way, you can click the help. So this shows you how the Teemer-Coates permeability works. Basically, you select down here a T2 cutoff, which it will also show in the log set, and a constant value. And then it uses this formula to calculate the permeability based on the cutoff. And similarly for the SDR, you need a T2LM and a phi NMR, total NMR porosity, and that with a constant and some exponents that you can set up here, you get a permeability. And so one thing I want to point out is the reason I can already calculate one is because we have both NMR porosity and T2LM in the Earth model. Now, the difference is because I didn't calculate the Earth model inversion, I have to use the RD values. And so I'm going to go ahead and I'm going to call this EM. And we'll see that this we can use this later as sort of a reference for what where we started. And so, oops, I didn't mean to do that. Just to make this more clear, I'm going to do this one more time with, so that way I get it in a different log set. Okay, so now now we can plot on the simulated data as well, both the simulated log, make this bigger, and we'll make the screen like the other one. Okay, so there's the T2LM for the simulated data, and that doesn't seem quite right. Did I pick the wrong one? Oh, T2, pick the wrong one. Yeah, there we go. Okay, so there's the T2LM, and then we can also plot, the reason I wanted the TC is because in here we have the T2 cutoff. And so that's useful if you want to see, okay, where is that cutoff that we're using to do that evaluation? And we can also plot that in phi. We can use the same cutoff because that way it'll show us for this, for our calculations, you know, how our calculation compares to the data that we imported. And so I'm going to click the T2 there, pick the cutoff, change this also to red. Oops, where it happened, depth cutoff. There we go. Okay, so now you can see clearly we don't expect that our at least our T-mer coat's permeability is going to match because the distributions relative to the cutoff are completely off. But we can go ahead and plot those anyway. So let's go to the permeability here and plot some of these permeabilities that we calculated. So simulated logs. Let's first do the SDR Earth model just to get a reference frame for that. And we're going to want to plot these in logarithmic. And probably about 8, maybe 0.03. Okay, so there's our, this is from the SDR that we calculate from our relaxivity domain calculations in the Earth model. And then we can also plot, oh, we didn't do the, okay, now that we have simulated T2LM, we can also do and make an SDR from the simulated. And so we need a T2 log mean. And then here we also do simulated, and we'll pick. Now the TC, another thing I want to show is that the TC permeability log set, not only does it have the TC permeability, it also has the bound fluid fraction. It also has the total phi NMR, and as well as the cutoff that we've already plotted. So here I'm going to select the phi NMR. So now we have a T2 log mean and a phi NMR, which is what you need for the SDR. And so this one I'm going to call SDR sim, and I'll just put that in here. Okay, so that's done, and now we can go back here and we can plot SDR permeability. I think we might have to. Okay, SDR perm sim. Okay, and that's pretty close. And then let's plot also the T-mer coats. Okay, so we can see, not surprisingly, that the T-mer coats is way off down here because obviously all of our distribution is below the cutoff as opposed to where it should be. However, the SDR uses different properties, so these so far seem to at least be comparable to each other here, which is not surprising since they're based on a simulation and an Earth model calculation. But we can see up here, you know, they sort of give very high values that we might not expect. There's no reason to expect that this section of reservoir is going to have different values. So what can we do here? We're going to go in and change some values. And there's a lot of things now because the NMR uses just about everything in the Earth model. But one of the main things that I'm going to show you here is, because we can clearly see that this is a bimodal distribution. So what I'm going to do is, for the default rock class, create a bimodal distribution. And I'm going to change these values to sort of change the width and the centers of these values, and make this okay, and then there's I'm not going to go into all the things you can do here. Basically, this thing, when you're using the time domain, you can have all these different functions of pore radius distribution, and there's a separate distribution for the shale, and so we're going to modify that as well, and make that a little bit wider because the peaks seem to be spread out some. Okay. So now I've changed that. And we also notice that down here, there seems to be a different type of shale down here. So I'm going to make a separate rock class here. So I'm going to go quickly into rock classes and add a rock class 1, and then go back into the NMR curves from here. And for rock class 1, I'm just going to move these things around a little bit. I'm going to make this a little bit lower, 0.2, leave that with 0.1, and then down here, I'm going to make this really small. And okay, and then the last thing that we have to do now that we have another rock class is we need to go in and make sure that we set that down here in the, I made a custom table here, and we can change the rock class in the bottom layer there to use that new one that we made. All right, so now, oh, and one more thing I'm going to do is I'm going to customize a little bit because we know the range that we're looking for in our T2 values. I'm going to extend our sequence to cover those values a little bit better. All right, so now we're going to run this again. Should be a little bit faster because we're just using the time domain. And now this is just sort of the workflow that you can then repeat multiple times to try it, where you do some changes, run the calculation, then we're going to run the simulation, and then we're going to invert that simulation and then see what effect it has on the plots. So now we'll go here. We have that new time domain data, so we run the simulation, and then we'll invert that here. And it's just going to write right over the one that we had because we're using the same data set. And then we can see if we got any closer to this, and then we'll update our permeability logs and see what happens with those. And this just takes a few seconds. And so one thing that you'll see in the, there's also for each of these next sessions, there's an exercise that you can do yourself. And the exercise will address the reason that you don't see these, or why you see this strange behavior in the permeability, as most of you know. It's because the permeability calculations assume that you have 100% water. In this case, all our hydrocarbon is messing up our permeability calculations. But nonetheless, we can see if we can get a little bit closer. And so now we got that inversion. So let's see if that improved this at all. And so if we look here, we can see now it looks a lot better as far as we have the multimodal distribution. It sort of is on top of the T2, similar to this one. You know, maybe this part isn't quite matching as well. Down here, we have the two different distributions here that we saw, and up here that looks like this shale is matching fairly well. And down here and up here, this is matching not too well. So now what we could do is we can just rerun this NMR data, and we can rerun these these log sets. And then we'll turn those off and just run the SDR again. Okay. And then up here, we should be able to see that these have updated if we run the SDR permeability simulation. Where is our, oh yeah, so our, what we see now is that the T2, or the teamwork coats now is up here, rather than having that really low. So now it's a little bit closer to where these others were. And so that this has value of like 40 or something. These are still showing kind of low. Calculate the log mean. I think I did. Well, these are on top of each other. It looks like they're still showing, they're showing kind of low, but anyway, so we're done with this. The main point is that I wanted to show that you can improve the, or you can try to change things in the Earth model to then use a simulation to match the data that you bring in, and then do NMR permeability calculations with a couple of different sets. And if you follow the exercise, then you'll see that that in fact you can get this to be fairly uniform all the way up, matching the permeability you expect. When you, well, it shows you how to do water substitution, fluid substitution. All right.